Hello guys, let's solve another linked list problem, reverse linked list. It's 206. We were solving all the blind 75 questions from Leetcode. So we are going to starting from Leetcode, linked list here. And the problem we are going to do reverse the linked list. This is an easy problem. There are multiple ways to do it. One way actually, you can write some iterative algorithm where you can go through the list and update this list. But for this video, I want to do it a little bit differently. We want to reverse the linked list, but we want to do it using a recursive way. So just to give you guys some idea how the reverse or the whole thing works as a recursion. So let's start with the base case. So when you are focusing on writing any recursive algorithm, focus on the base case first. So if you have only one node with one, then you want to just return that one because that's your linked list. If you even reverse it, right? So if you have item with two node like 1 and 2, so you basically want to return the list like 2 and 1. So let's try to figure out how we can implement these ones. So if you're either you have one node or actually only null node, then you just want to return that head. But to recursive algorithm to work, like 1, 2, if you want to make it 2 and 1, let's see how we can do it. So if you have only one node, basically it's pointing to a location with a none, right? Because that's your next location. Even if you reverse it, it will be the same, 1, none. But for 1 and 2, you can think about, so if 1 is your first node, just for the sake of it, we'll call it P. And then this is your current node. So P for previous and C for current node. What we want to do, you can see for the next result, when you are reversing your current node.next actually becomes your previous node, right? So we need a different algorithm, different functions, because if you want to write a recursive function, so for this one, I'll just copy this whole thing as a function signature and change the name here. We'll call it maybe reverse recursively. So we need a few things. We need actually the previous node, because without previous node, we can't reverse it using recursively, and the current node. So we'll have head same as previous, but what we'll do, we'll get one more variable from here, which is basically a read. So for the base case, if our first this pre is none, we basically want to return that head, right? So if your pre is none, so let's take a step back. So you want two values, pre is 1 and the current node is 2. So for this case, what you want to do actually, when you have only these values like 2, then you want to return just 2, right? So if your head is none, like the current one, you want to return only the previous node. And what we want to do for a larger list like 1, 2, 3, 4, 5, we want to get the tail, which we can get it from head.next. So we want to separate these two things out. So if you have multiple values like 1, 2, 3, 4. So if you have these 4 values, and if you have so this is your basically the tail, and this is your head, right? So we got the tail, and for this tail we want to reverse the whole thing too, right? So using this tail, and what we will do with this guy, so if we know what the result would look like, if this is your head, we want to point to the previous node here. So basically what you want to do, head.next equal pre. So you got the head current node, you are updating this pointer, and basically then you just return your same function, but actually recursively. And right now you will pass it with the head of the tail. And for this one, the main function you can basically return if your head is none, you can just return head or none. Both are fine. Otherwise, you want to call this reverse self dot reverse recursively. You want to pass it on the first parameter as a none, which is your previous node, and you want to pass it this head. So let's see if we can pass all this test. So it seems like a run will submit a little bit later. So let's talk about what are the things we have done. We have recursively called n items every time. So the runtime complexity obviously order n. If you use recursive algorithm, most likely you need to add those things into the stack. So that might be order of n extra storage. So you can solve using recursive algorithm. But the recursive algorithm is very cleaner approach to do it. But you need to understand a few of the nuances of recursive algorithm. So let's submit it, and then let's see if you get excited. Yep. So you can beat almost 100% of the existing algorithm with 0 millisecond. So that's a good way to do it. The other way, actually, you basically keep track of 3 variables if you want to do it in iterative method, where you basically take the node, current node, and also the next node. And in each step, you basically update these 2 pointers. If you do it in iterative way, that's better from the space complexity wise, because you will need only constant space. You can still solve it in order n. Yeah, thanks for watching. I'll see you in the next video.